Now let me solve problem number 1.49 for you. A solid body rotates about stationary axis so that its angular velocity depends on rotation angle as this. Omega is equal to omega naught minus a phi, where omega naught and a are positive constant. Omega naught is a constant, a is also a constant, a positive constant. At time t equal to 0, phi is equal to 0. Find the time dependence of rotation angle and the angular velocity. Now, angular velocity is given as a function of phi, angular displacement. I will say this angular velocity is d phi by dt and it's omega naught minus a phi. So I will rearrange this differential equation like this: d phi upon omega naught minus a phi is equal to dt, and now I will integrate it on both the sides. D phi by omega naught minus a phi is equal to integral of dt, and while integrating I will say at 0 time angular displacement is 0 and at any time t angular displacement is phi. Now we will integrate this function. We know the integration, it's minus 1 upon a ln of omega naught minus a phi over 0 to phi, and this integral of dt is t over 0 to t. Now I will substitute the limits. We will get it equal to omega naught minus a phi minus ln of omega naught is equal to minus a t minus 0, and this would give me ln of omega naught minus a phi upon omega naught is equal to minus of at, or 1 minus a phi by omega naught is equal to e to the power minus of at, or this would give me phi as a function of time, which is omega naught upon a into 1 minus e to the power minus at. This is phi as a function of time, and in order to get the expression for omega as a function of time, I will say it's d phi by dt, or omega is, I will differentiate this function and I will get it equal to omega naught e to the power minus at. I can plot the variation of omega with time and phi with time. Omega with time would go exponentially like this, omega naught, and phi with time would increase exponentially like this, where this is equal to omega naught upon a, omega naught upon a. There is exponential decay. Note it, angular velocity as a function of angular displacement. This angular velocity, we wrote its definition, it is d phi by dt. We got this differential equation. We rearranged this differential equation. We integrated it like this. हमने phi की सारी टर्म्स एक तरफ इकट्ठी कर ली, टाइम की सारी टर्म्स एक तरफ इकट्ठी कर ली. Lower limit 0 time पर phi is 0, at any time phi is phi. We integrated this function. We know the integration. Definite integration. We have put the limits, and then we simplified this equation in this manner in order to get phi as a function of time. Then after getting phi as a function of time, or angular displacement as a function of time, we applied the definition of angular velocity, which is d phi by dt, and we differentiated this function with respect to time, and we got the expression for angular velocity. We can always plot this graph. Now I will solve problem number 1.50 for you. Let's read the problem statement. A solid body starts rotating about a stationary axis with angular acceleration. Angular acceleration is beta naught cos phi. Beta naught is a constant vector and phi is angle of rotation. Beta naught is constant and phi is angular displacement. ठीक है ना? From initial position, find angular velocity of body as a function of phi. Draw the plot for this dependence. Angular velocity as a function of phi. Now, once again, I'll write the definition of angular acceleration first. This is angular acceleration. Angular acceleration. This angular acceleration, it would be defined as d phi by dt and it's beta naught cos phi. अब एक स्टैंडर्ड कंसेप्ट हमने समझ रखा है, देख रखा है, मैं एक और बार उसको रिकॉल जरूर करा दूं. Whenever angular acceleration is given as a function of angular displacement, the standard operation that we do is, first of all we write d omega by dt as a function of phi, and when we multiply and divide it by angular displacement term, and then this d phi by dt is written as omega d omega by d phi as a function of phi, and then omega d omega is a function of phi into d phi, and then we integrate it on both the sides. This is the standard operation that we had studied in the theory. हमेशा ऐसा करते हैं, यह एंगुलर एक्सीलरेशन हो या लीनियर एक्सीलरेशन हो, यदि यह एंगुलर डिस्प्लेसमेंट या डिस्प्लेसमेंट के टर्म में दे रखा है तो हम ऐसा करते हैं, पहले डी ओमेगा बाय डी, फिर डी फाई से मल्टीप्लाई डिवाइड, एंगुलर डिस्प्लेसमेंट से मल्टीप्लाई डिवाइड करते हैं. वही काम हम इधर करने जा रहे हैं. डी ओमेगा बाय डी फाई इनटू डी फाई बाय डी टी इज इक्वल टू बीटा नॉट कॉस फाई, और फिर मैं डी फाई बाय डी टी को लिख दूंगा ओमेगा. So this equation will reduce like this, omega d omega by d phi is equal to beta naught cos phi. अब मैं d phi को ऊपर ले जाऊंगा और इस तरह से इस इक्वेशन को लिख दूंगा, omega d omega is equal to beta naught which is a constant cos phi d phi, and then I'll integrate it on both the sides like this. Initially when phi is 0, omega is 0. When phi is phi, this sum omega naught, and its integration is omega square by 2. I'll write it like this, omega square by 2 from 0 to omega, and its integration is cos phi, its integration is sin phi from 0 to phi. So this would give me omega square is equal to 2 beta naught sin phi, or omega is plus or minus under root of 2 beta naught sin phi. This is the desired answer, the desired result. Now, they're asked to plot for it, to plot for phi versus how angular velocity and angular acceleration varies with phi. So, first of all, it's under root of sin phi. Phi could never take negative value. Phi must be always greater than equal to 0, less than equal to 2 pi. Phi can never take negative value. Sin phi, in fact, up to pi. Sin phi must be always positive, or sin phi must be greater than 0 and less than equal to 1. Negative नहीं हो सकता. Hence, I will say here I will plot for phi. This is phi equal to 0. Here we will have pi by 2 and here we will have pi. Now, first of all, let me plot for omega versus sin phi. Omega versus sin phi would be something like this, elliptical. Sin phi would be something like this. Let me draw it neatly. It would be like this. When this phi is pi by 2, it would take the maximum value, and that maximum value would be plus under root 2 beta naught or minus under root 2 beta naught, and it would take 0 value at phi is equal to pi. And if I plot for, this is for omega. If I plot for beta, this value would be like this. This for beta. When phi is 0, it's plus beta naught, and when phi is pi, it's minus beta naught. This is the value, and it's 0 when angle phi is pi by 2. Observe this graph and observe the complete solution. Once again, the definition of angular acceleration d omega by dt is beta naught cos phi. And when angular acceleration is given in terms of as a function of angular displacement, you multiply and divide it by d phi. You multiply and divide it by d phi, and then d phi by dt can be written as omega, and this function would reduce as omega d omega by d phi is equal to function of phi. वही काम हमने इधर करा है. Angular acceleration as a function of angular displacement, d omega by dt पहले लिखा और d omega by dt को d phi से मल्टीप्लाई डिवाइड कर दिया, d phi by dt को omega लिख दिया, omega d omega by d phi is equal to beta naught cos phi. हमने रीअरेंज कर दिया, d phi ऊपर ले गए, phi की सारी टर्म्स एक साथ, ओमेगा की सारी टर्म्स एक साथ, ओमेगा d omega का इंटीग्रल ओमेगा स्क्वायर बाय 2 और cos phi d phi का इंटीग्रल sin phi. लिमिट्स लगा दी and we get the expression for omega, and then we plot it like this. Please note it down.